Hi everyone, Dr. K here. Today I am going to talk to myself about forensic science. One of my favorite topics, not only because it's a personal research interest of mine, but also because I think it's a topic that most people find really surprising when they learn what forensic science really is and what forensic science really isn't. So far, we've focused mainly on two causes of wrongful convictions. We talked about eyewitness misidentifications, and we've talked about false confessions. A third common cause of wrongful convictions, as you can see on the graph here, is the use of false or misleading forensic evidence. In other words, mistakes or fraud committed by forensic scientists. It's found in approximately a quarter of known exoneration cases. This graph is a little outdated. That number is up around 600 cases now. So 600 times where an innocent person has gone to jail because of a mistake, knowingly or otherwise, made by a forensic scientist. So the long story short of this lecture is going to be that forensic science does not work the way that TV shows would make you believe that it works. The average person thinks that forensic science is highly reliable, very automated, very objective, lots of technology involved, but in the real world that's not the case, especially for some forensic science disciplines, as we'll talk about later today. They are highly reliant on human judgment. And we know that anytime humans are involved, there's the potential for bias and error. So that's what a lot of my own personal research has examined is when do forensic scientists make mistakes and why? And what sorts of things can we do to prevent those mistakes? So the latter half or latter two-thirds of this lecture is going to be focusing on unconscious bias, cognitive bias, and how it can actually interfere with forensic scientists' ability to do their job unless we do something about it. First, we should take a step back and talk about what the forensic sciences actually are. When most people hear the term forensic science, the first things that come to mind are fingerprints and DNA. But in actuality, there are lots and lots and lots of other disciplines of forensic science as well. This is not even close to an exhaustive list, but you've got shoe print comparison, document handwriting analysis, ballistics analysis, hair analysis, bite mark analysis, blood spatter, tool marks, tire tracks, bodily fluids, arson, the list goes on and on. There's a whole bunch of different forensic sciences out there. As you probably got a sense from reading not only the 5 Disturbing Things article for today, but also the summary of the National Academy of Sciences report, which we'll come back to later. The forensic sciences are a very, very diverse set of disciplines, but what a lot of them have in common is that they ask a human examiner who is trained and specializes in one particular type of evidence to compare two samples. One where we know where it came from, and one where we don't know where it came from. In other words, the known sample comes from the suspect, and the unknown sample comes from the crime scene. So we might have, for example, a footprint that was found on the crime scene that we can compare against the suspect's shoe. Or we might have a tire track that was found at the crime scene that we can compare against the suspect's car. Or a bite mark found on the victim that we can compare against the suspect's teeth. And the job of the examiner is to look at these two pieces of evidence and make a judgment about whether they match, right? Did the suspect make this bite mark? Did the suspect's car make this tire track? And so on. Obviously, if they do match, that implies that the suspect is guilty. If they don't match, it implies that the suspect is innocent. So the first question we might want to address here is, are forensic scientists any good at this? Can they actually do what they claim to be able to do? If we give them 2 fingerprints, can they tell us whether or not they come from the same person with any degree of accuracy? Thankfully, the answer to that question, at least with respect to fingerprints, appears to be yes. So this graphic comes from one study that looked at fingerprint experts' ability to match fingerprints compared to untrained novices. So the blue bars represent experts' accuracy rates, and the green bars represent novices' accuracy rates. And what happened in this study is they gave the participants, whether they were experts or novices, two pairs of fingerprints to compare, some of which actually matched, some of which didn't actually match. And of the ones that didn't match, some looked similar and some looked dissimilar on the surface. As you can see from the heights of the blue bars, experts were quite good at this, and they were consistently a lot better than novices were, right? 100% of the time, for example, the experts correctly determined that the non-similar prints did not match each other. 92% of the time, they were able to correctly determine when two prints did in fact match each other. And for the more difficult comparisons, where they were given two prints that looked similar but actually were different, that's where we saw the biggest difference between trained experts and novices. So there's little doubt that fingerprint expertise does exist. There are people that are very good at this. However, this is a study, right? This is not necessarily an accurate representation of what happens in the real world. So while on the one hand, I think these results are important because it shows that fingerprint experts do have a skill that the average person doesn't have, we might not put too much faith in the exact numbers that came out of this study. Because as you can see from the stimuli that were used, from these pictures of the fingerprints on the left side of the slide, this test is pretty unrealistic in terms of what actually happens in the real world, right? The people in this study were given complete, pristine fingerprints to compare. Whereas if you're looking at a fingerprint recovered from a crime scene, it may not be a complete print, it may be smudged, it may be incomplete, and there was also no consequences in this study, right? There's no consequence to making a wrong decision, there's no pressure from investigators to solve the case. So what we're looking at here, while I would say it's encouraging, is probably the best case scenario, right? These are judgments made under optimal circumstances, which is often not the case in the real world. And in fact, when we look in the real world, we see that fingerprint examiners often disagree with each other. So in the study that I'm going to tell you about on this slide, they gave fingerprint examiners who didn't know they were participating in a study. That's an important caveat here. Experts who didn't know they were participating in a study, they gave them fingerprints to look at. And for each fingerprint, they asked them to count the number of what are called minutiae in the fingerprint. Minutia is a fancy word for features of a fingerprint that make a person's fingerprint unique. So if you ever take a class on fingerprinting, you'll talk about things like arches and whorls and loops. These are the different features of a person's fingerprint that allow fingerprint examiners to distinguish one person's fingerprints from another. And while it's always been assumed that no two people have the same fingerprints, that's never actually been tested. It's just kind of assumed. But it's, you know, as you can imagine, that's something that's very difficult to prove. Anyway, in this particular study, they gave the same fingerprints to 10 different fingerprint examiners and asked them to count the number of minutiae in those prints. What they found is that examiners disagreed with each other quite a bit when they were looking at the same fingerprint. So let's take fingerprint D, for example. This is 10 different fingerprint experts all looking at the same fingerprint and all trying to count the number of minutiae in that fingerprint. Some examiners found as few as 6 or 7 minutiae in the print. Others found as many as 13 or 14 in the same print. They're looking at the same thing, but seeing very different features. So there's clearly a degree of judgment, a degree of subjectivity involved in this. Different examiners are using different criteria, different methodologies for analyzing fingerprints, and accordingly they're coming to different conclusions. What's even more alarming is in this same study, they had examiners, again without their knowledge, examine the same fingerprint on 2 different occasions. And what they found is that not only were perceptions of the same fingerprint different between different examiners, they were also different within the same examiner over time. So this table shows the difference for each examiner in the number of minutiae that they saw in the same fingerprint from one day to another day. Examiner 2, for example, analyzed fingerprint A twice, but one of those times they saw 8 more minutiae in the same fingerprint on one day than they did in the same fingerprint on a different day. Again, it goes to show that fingerprint analysis, even though it tends to be one of the better forensic science domains, still has an element of subjectivity involved in it. There's examiners having to make judgment calls here. And anytime there's subjectivity involved, as we'll talk about later today, there's a potential for bias to affect people's judgment. Now, as I just mentioned, fingerprint analysis is one of the more reliable forms of forensic evidence that are out there. What about some of these other types of forensic evidence? Blood spatters and shoe prints and bite marks. What about them? Rather than having me tell you about it, I'm going to have you watch a little clip from John Oliver, a fantastic TV show. I would encourage you to watch this whole episode if you have the time, because it's really funny, it's really good. But at minimum, please watch at least from 4:28 to 7:55, and you'll hear John Oliver talk a little bit about blood spatter, hair, and bite mark analysis, and the degree to which it is scientific. Alright, I hope you enjoyed that video. Next week we'll actually continue talking about bite mark analysis a little bit when we delve into a case study of a man who was wrongly convicted, partly due to a false confession, but also largely due to flawed bite mark evidence. But the takeaway message from this John Oliver episode is it is really alarming how little science there is in forensic science. A lot of these disciplines have never been tested to even show that examiners can do what they claim to be able to do. Is it even possible to match bite marks? Is it even possible to match shoe prints? Those are questions that have never really been answered, but still that evidence gets presented in court and often goes unchallenged, precisely because it's been used for a long time. And it isn't until maybe the last 10, 15 years or so that people have really cast a light on forensic science and said, wait a minute, should we be trusting this or not? Is there good reason to believe that this evidence is trustworthy, or do we kind of need to go back to the drawing board here? And you probably saw John Oliver in that video make mention of the NAS report. So this is a report which you read the executive summary of for today. This is a report that came out in 2009 that was very critical of the forensic sciences. So the impetus behind this report is that the National Academy of Sciences and the National Institute of Justice, they sponsored a report to essentially do a comprehensive review of what are the forensic sciences like in the United States. What kind of research is there? What kind of procedures are there? What kind of training is there? Just everything that we might want to know about forensic science. And to be honest, it painted a very, very bleak picture of what forensic science is like. So the conclusion is as follows. With the exception of DNA, so they recognize that DNA is very strong and has a strong scientific foundation. They say no forensic method, not fingerprints, not shoe prints, bite marks, handwriting, blood spatter, you name it, no forensic method has been rigorously shown to have the capacity to consistently and with a high degree of certainty demonstrate a connection between evidence and a specific individual or source. In other words, the takeaway message from this report is there's really not good evidence that any of these forensic sciences, other than DNA, can actually do what they claim to be able to do, can actually match a shoe print to a shoe, or a blood spatter to an injury, or a handwriting to a particular person. The evidence just doesn't exist. And, if we dig a little deeper, what they also found in this report is that there is a tremendous amount of variability in terms of how these forensic sciences are actually carried out in the real world. Some fingerprint experts might have a bachelor's degree, others have PhDs. Some have 1 year of training, some have 10 years of training. They might use different methodologies, different equipment. There really isn't much in terms of standardization, standard procedures, standard reporting practices. It's kind of just the Wild West out there. Everybody's doing their own thing and hoping that it works, but very little evidence, in some fields more than others, that it actually does what it's supposed to do. And as I mentioned before, lots of evidence that this is a very subjective endeavor. It's not people using computers and really objective analysis. It's people who are human doing the eyeball test and leaving it up to their own judgment as to whether these things match or not. Which brings me to the next and what I think is a very important point that the NAS report made, which is that the judgments of forensic scientists are vulnerable to unconscious bias. You've probably talked in other psychology classes or seen in the news things about implicit bias, right? Things that affect our judgment that we're not even aware of, whether it's implicit racial bias or confirmation bias or hindsight bias or any number of other things. What has become increasingly clear over the last 10 years is that forensic scientists are not immune from this. They're biased just like everybody else is biased. And that unconscious bias can affect their work in ways that lead to very, very costly mistakes. So what I'd like to do for the next little while is just talk in very general terms about what confirmation bias actually is, and then we'll jump back into forensic science and see how exactly it plays a role in shaping forensic scientists' judgments in a way that is problematic. If I were to show you this image, you would, like most people, read it from left to right as ABC, right? But if I showed you this image, you would read it from top to bottom as 12, 13, 14. Now, regardless of how this is presented, the stimulus in the middle remains the same, right? But depending on the context, we read that same stimulus as either a B, if it's surrounded by an A and a C, or as a 13, if it's surrounded by a 12 and a 14. This very simple demonstration makes a very profound point, that the same exact information can be perceived very differently depending on the context in which that information is presented. Or in other words, the same information can be seen differently depending on the expectations of the person who's looking at it. Am I expecting a letter or am I expecting a number? When we process information, when our brain makes sense of something, first we see that thing. So here's an image right here. The first thing that our brain does is we get that image into our brain. The process of getting that image into our brain in psychology is called bottom-up processing. It's just the very sort of objective, physical process of getting this sensory information into our brain so that we can make sense of it. So bottom-up processing is more or less the same for every individual, right? Every one of you who's looking at that image is seeing, in a physical sense, the same thing. What sets people apart, though, is how they might interpret that image. So once we get that image into our brain through bottom-up processing, our brain then uses a process called top-down processing to make sense of it. Now here's where different people might differ from each other. Everyone is looking at the same image, but you might have a different interpretation of that image than somebody else. That's where top-down processing comes in. Top-down processing is the subjective component of processing information. So when I first put that image on the screen, some of you probably immediately saw a woman's face. Others probably immediately saw a man playing the saxophone. even though you were seeing the exact same image, the same information, your interpretation of it could have been in either of those ways, right? And maybe your interpretation was shaped by your own personal experience. For example, maybe if you yourself are a woman, you were more likely to see the image as a woman. Maybe if you are a musician, you are more likely to see it as a saxophone player. But the point is, everyone is getting the same bottom-up information. What sets people apart is their top-down interpretation of that information. And what that can produce is a phenomenon called confirmation bias. Now, confirmation bias, generally speaking, means that when we hold a belief, we, without realizing it, we tend to seek out, interpret evidence in ways that supports our belief, strengthens our belief, and ignore evidence that contradicts our belief, okay? You're going to see a lot of this over the next couple months with the election, I bet. If you had, say, someone who is a Democrat and someone who is a Republican watch the same political debate and you asked them who won the debate, they're going to pick their person, right? Because they're going to, without realizing it, focus on evidence that their candidate is the better candidate and ignore any faults in their candidate. In other words, their brain sort of has a filter that filters out information that disagrees with our beliefs and filters in information that supports our beliefs. So this cute little cartoon on the right-hand side kind of illustrates that, right? Everything you look for and all that you perceive has a way of proving whatever you believe. It's sort of consistent with the idea of a self-fulfilling prophecy that if we want to believe something, we will find evidence to support that thing. Now, I want to be really careful in how we talk about confirmation bias, because you've probably seen in the news stories about forensic scientists committing fraud. And there have been a lot of those, and those cases are very problematic, right? Here's one case from Massachusetts, for example, where one woman falsified lab results for a whole bunch of forensic tests. I want to be clear that when we're talking about confirmation bias, we're not talking about fraud, okay? The term bias tends to have a really negative connotation, but bias is not the same as fraud. It's not the same as being careless. Being biased doesn't mean you're incompetent. Bias just means that you're human, right? It's a byproduct of how the brain actually works. You're biased, I'm biased, everyone is biased, right? Being an expert doesn't protect you from it. Being highly trained, highly skilled, really smart, really ethical, none of that protects you from it because it's just a matter of how the brain works. Expectations are very powerful. And when we hold a strong expectation, that expectation tends to shape how we interpret information. Here's a study that demonstrates that in a simple and I think pretty clever way. In this particular study, they had people look at photos, and each photo had two people in it, so photos that might have looked something like this. And they told the participants in this study one of two things. They either said the two people in this photo are related, meaning, mother, daughter, father, son, whatever it might be, or they told the people that the people in the photo are not related, that they're just friends or colleagues or business partners or whatever it might be. And then they asked those people to rate on a scale of 1 to 7, I think it was, how similar do you think these people look? How similar looking are these people? Now, you can relate to this study if you've ever had somebody tell you that you look just like one of your parents, right? And maybe you think, well, I don't think I really look like my mom. I don't think I really look like my dad. The question that this study set out to answer is, will people think that you look more like your mom or dad merely because they know that that person is your mom or dad? In other words, are their expectations shaping your perception? And that's exactly what they found in this study. What they found is that when the person looking at the photo was told that the people in the photo were related to each other, they saw those people as looking really similar. They thought that their faces looked the same. But when they were told that the people in the photo were not related to each other, they tended to see them as not looking that similar, even when they really were related. In other words, a person's expectations of how similar these two people should look was actually more important than whether they actually were related or not. Such that, again, we ended up with a situation where two people with different expectations look at the same photo and come away with very different interpretations, but each of them came away with an interpretation that matched what they expected going into it. If I think that they're related, I'm going to see them as looking very similar. If I think that they're not related, I'm going to look at the same photo and see them as looking not all that similar. When I was a graduate student in New York, this is a little fun exercise I like to throw in here. When I was a grad student in New York, I became friends with an elderly guy who was a forensic handwriting expert, who for decades has been, spotting forgeries and trying to, root out documents that are inauthentic. He was very, very into the practice of handwriting analysis, meaning, figuring out if a signature is fake, for example. So we're going to try. We're going to test our own ability to do this. This is Mickey Mantle, a legendary baseball player for the New York Yankees, and this is what Mickey Mantle's signature looks like. So I'll tell you right now that this is Mickey Mantle's actual signature. Now, the first time that I visited this handwriting expert who I was just telling you about, when you walk into his office, he's clearly not only into handwriting, but also a big baseball fan. And he has a whole shelf of autographed baseballs in there. And the first thing he does with everybody who visits his office for the first time is he takes them over to this shelf and he shows them two baseballs, both of which are signed by Mickey Mantle. And he says, one of these is fake. Which one do you think is the fake one? So I'm going to pause for a minute and just give you a minute to look at these two baseballs. One of these baseballs is actually signed by Mickey Mantle. The other one is fake. Spend a minute looking at this and try to decide which one do you think is fake, which one do you think is real, and why do you think that? All right, everybody got your mind made up? Now, if we were in class right now, I would ask you to tell me the sorts of things that you looked at when you were making this decision, right? And usually the first thing that people say is that they were looking at individual letters. So for example, you might think that this one is fake because the M here looks pretty different from the M up here, right? But you might think this one is fake because you'll notice in the authentic signature you have a little loop in the M, which you do have here, but you don't have over here. So I think just from looking at the signatures themselves, it's kind of hard to tell which one is real and which one is fake. So maybe if you gave up on trying to figure out based on just the letters, maybe you started to look more at the baseball itself. And you might have noticed that the baseball on the right is a little older looking than the baseball on the left, right? The baseball on the left is bright white, whereas the one on the right is a little faded, a little brown. And we know that is what happens to baseballs over time. Now, if you know that Mickey Mantle is an old baseball player, meaning he would have had to sign this baseball probably 20 years ago before he passed away, maybe you would look at the baseball on the right and say, well, I think that's the correct signature, because the baseball looks older. Now, if you did that, you would just so happen to be correct, right? The one on the right is actually signed by Mickey Mantle. The one on the left is a forgery. However, if your decision was right only because you looked at the baseball and not because you looked at the signature, I would say you are not actually a handwriting expert. You are somebody who knows how baseballs work. Everybody see what I mean there? If you are a handwriting expert and you are making decisions based off of handwriting, that's exactly what you should be focused on. You should not be focused on other information that is arguably irrelevant to making your decision. If in the same way, in the real world, if your job is a fingerprint expert, your job is to analyze fingerprints. If your job is a shoe print expert, your job is to analyze shoe prints. So the argument here is that forensic scientists should limit their analysis only to the information that is relevant to whatever they're trying to do, whether it's a signature, a fingerprint, a hair sample, whatever it might be. As soon as forensic scientists start relying on other information that goes outside of their expertise and is irrelevant to the question at hand, it undermines their expertise, right? If the only reason you got this right is because you looked at the baseball rather than the signature, you may be correct, but that doesn't make you a handwriting expert. I want to tell you about 2 cases where similar issues came up. 2 wrongful conviction cases. In each of these cases, a forensic scientist made a judgment, and then they learned that the person in question had given a confession. And in light of the confession, they changed their judgment. This should remind you of the phenomenon of corroboration inflation from a few weeks ago. So, first I'm going to tell you about Barry Loftman. Barry Loftman was a man who was a suspect in the rape and murder of his elderly neighbor. And the forensic evidence suggested that Barry Loftman could not have been the person who committed this crime, because the fluid evidence that was found on the victim's body indicated that Barry Loftman had type A blood, but the person who committed the crime had type B blood. So it couldn't possibly be Barry Loftman because the fluids didn't match. So that was what the blood analyst initially said, is that there's no way that this person could have committed the crime. However, Barry Loftman, who suffered from an intellectual disability, was interrogated by police using the Reed technique for a lengthy amount of time, and eventually gave a false, of course they didn't know that at the time, but gave a false confession to having committed this rape and murder. After Barry gave his confession, police made sure that the blood analyst was aware that Barry had given this confession. So think about, for example, that alibi study that we talked about a few weeks ago in the context of corroboration inflation, right? Now we have police going back to the blood analyst and saying, well, you told me this person couldn't have committed the crime, but they confessed. So now what do you have to say? And in this case, what the blood analyst said is they came up with a theory about how the blood type could have changed. How the blood type in the sample actually could have changed from type A to type B, making it possible that Barry actually did commit the crime and that his confession was true. In other words, same evidence, different context. The blood analyst changed their mind after learning about the confession, and unfortunately Barry ended up serving 16 years in prison for this rape and murder that he did not commit. Another case, and this goes back to last week a little bit, this was a juvenile case. Tyler Edmonds was a 13-year-old in Mississippi who, his sister had a boyfriend, and the sister's boyfriend was shot and killed. And Tyler gave a voluntary false confession to having killed his sister's boyfriend. The reason being that Tyler was a juvenile, Tyler's sister was an adult, and Tyler thought that by confessing, he would be able to protect his sister from getting a harsher punishment. Now, in Tyler's confession, he wasn't completely willing to take all of the blame. Instead, in his confession, what he said was that him and his sister both simultaneously held the gun together and pulled the trigger together when they fired the shot that killed his sister's boyfriend. Later, a ballistics expert was given the gun and the bullet to analyze to see whether the bullet had in fact been fired by that gun. And in so doing, the ballistics expert was made aware of Tyler's confession. Because of that, the ballistics expert actually testified that he could tell from the marks on the bullet that the trigger of the gun was pulled by not one but two fingers. Now, there is no basis for that conclusion whatsoever other than Tyler's confession, which later turned out to be false. So again, we have a situation where the ballistics expert's opinion was clearly shaped by their knowledge of the confession, and it led them to present evidence in court that was unreliable. That brings me to one of the studies that you read for today, by E.T.L. Dror and colleagues, published in 2006. The motivation for this study was the Madrid train bombings. You may vaguely remember this. I think it was 2003 that this happened, so it wasn't long after September 11th. There was a terrorist attack on a train in Madrid where they recovered a fingerprint on a bag that contained the explosive devices. So they had the fingerprint of the person who committed this crime. They ran the fingerprint through computer software, and it identified a list of potential matches. One of which was the man that you see pictured in the bottom left, a man named Brandon Mayfield. And the FBI concluded that Brandon Mayfield was the person whose fingerprint was found on the briefcase, and therefore was the person who was responsible for the Madrid train bombing. Now, it later, long story short, was determined that that was not the case, and the FBI undertook a review of the case to figure out how did they make this mistake. How did they mistakenly conclude that Brandon Mayfield's print matched the print found on the train? What they concluded, among other things, is that there was that confirmation bias played a role in this decision. You see, when they compared Brandon Mayfield's fingerprint against the fingerprint found on the train, they also had some other information about Brandon. For example, they knew that Brandon was an attorney and that Brandon had recently defended suspected terrorists. And for that reason, he was on a no-fly list because some of his clients had been suspected of terrorism. They also knew that Brandon's wife was Muslim and that Brandon himself had recently converted to Islam so that his faith matched that of his wife. The FBI conceded that that information could have influenced the FBI fingerprint examiner's judgment and led them to believe that Brandon was guilty of this bombing when in fact he was not. Now, the common thread here is that the examiners had access to information that A, they shouldn't have necessarily had, B, they didn't need, and C, could have influenced their judgment about the evidence. Instead of basing their judgment solely on the evidence, they were basing it on other irrelevant things. So what Dror and colleagues did in this study is they took the prints from the Mayfield case. So on the left here, you can see that's Brandon Mayfield's actual fingerprint. On the right is what the fingerprint that was found on the train actually looked like. And we know that these fingerprints do not actually match. What Dror and colleagues did, which I think is very clever, is they gave those fingerprints to, they told fingerprint experts that they were going to be analyzing the prints from the Mayfield case. And this was such a high-profile case that all of the fingerprint experts actually, would have known about it. So they would have known that those prints shouldn't match, right? Because this was a very high-profile mistake. Those prints shouldn't match. However, what they actually did is they gave those examiners matching prints. Prints that they themselves had judged as a match earlier in their careers. So In other words, what these researchers have done is they've created a situation where, without realizing it, they're asking examiners to re-examine the same prints that they previously examined, but now in a different context. A context that leads them to expect that those prints shouldn't match. Now, this was a very small study. There were only 5 participants, 5 fingerprint examiners. But this was a groundbreaking study, and it was very, very important at its time. And what they found is that 4 of those 5 fingerprint examiners actually changed their own previous judgments of the same fingerprints. 80%, 4 out of 5, when they saw the same fingerprints in a different context, made a different decision. In other words, their judgment was clearly influenced by the context in which the fingerprints were presented and by their expectation of what the fingerprints should look like. Now again, while this was a very small study, it's since been replicated a couple times. It's clear that fingerprint experts are indeed subject to cognitive bias. If they expect the prints to match for whatever reason, they are more likely to believe that they will match, and vice versa. This same phenomenon has also been displayed in other domains. For example, forensic anthropology, analyses of bones and skeletal remains. In this particular study, they had people who were trained in forensic anthropology, and they gave them ostensibly true information about the skeleton. Among other things, they told them the sex of the deceased person, the age of the deceased person, and the ancestry, in other words, the racial or ethnic background of the deceased person. And they wanted to see whether that information would influence their judgments. So, long story short, they had different people examine the same skeleton, but armed with different expectations. And what they found, again, is that their expectations clearly shaped their conclusions. Some people were led to believe that the skeleton was a man. And when they were led to believe that the skeleton was a man, they, most of the time, concluded that the skeleton was a man. Other people were led to believe that the skeleton was a woman. And those people looked at the same skeleton and believed that it was a woman. They found similar effects for age, they found similar effects for ancestry. In other words, whatever people believed they were going to find is what they actually found. They were clearly influenced by their expectations. Arson, even DNA. There's even one study that found that DNA, as good and as scientific as it tends to be, is subject to cognitive bias. That there are situations in which 2 DNA experts might look at the same DNA sample, particularly if that DNA sample consists of a mixture of DNA from multiple people, and come away with different conclusions that are in line with their differing expectations. So this is a robust phenomenon of cognitive bias. We coined the term forensic confirmation bias to describe this phenomenon. And what we mean by that is anytime a forensic examiner has access to information that is irrelevant to their analysis, and that information influences their judgment, we would say that they have been affected by forensic confirmation bias. So for example, if an arson investigator knows about a person's prior criminal history, which they shouldn't need to be able to make a judgment. If a fingerprint expert knows about a suspect's confession, or if a bite mark examiner knows about a person's alibi, that shouldn't be information they need, right? Your job is to examine the bite mark, or the fingerprint, or the burn pattern. Your job is not to rely on the confession. In short, our argument is that forensic examiners should make their decisions based solely on the forensic evidence and nothing else. And fortunately, a lot of people tend to agree with that. So for today, I had you read the executive summary of the National Academy of Sciences report, which came out in 2009. But there has been a more recent report that came out in 2016. You can see here September 2016 from what's called PCAST, the President's Council of Advisors on Science and Technology. So these are some of the most prominent scientists in the country. So much so that they've been trusted to advise the President of the United States on scientific issues. And one of the conclusions that they drew about the forensic science is that contextual bias or confirmation bias can impact experts' decisions, and for that reason, courts and laboratories should take steps to ensure that forensic examiners aren't exposed to any information that they shouldn't be exposed to. So basically what they're saying here is there's no reason for a fingerprint expert to know about eyewitness information or a person's race or a person's criminal history or a person's confession. Their judgment should be limited solely to the fingerprints. That's their expertise, that's their job, that's what they should focus on. And they compared the forensic sciences against other sciences in a pretty unfavorable way, right? Anybody who knows anything about research knows that it's important that research be carried out in a blind or double-blind fashion, right? This is why drug trials include placebos, for example. We don't want the researchers or the participants knowing what the hypothesis of the study is, because we know that that could influence the results. Among other things, PCAST argued that forensic examiners should adopt a similar approach, that they should be blind to any information that they don't need that could potentially influence their analysis. Well, do examiners agree? Do examiners think that they should be blinded to irrelevant information that could potentially bias them? Or do they think that it's not a problem? After our article came out in 2013, we started noticing anecdotally individual examiners objecting to the idea that they should be blinded to biasing information. So what I've got here are a few actual quotes from forensic scientists talking about their own beliefs, their own attitude toward the topic of bias. 2007, the person who was then chairman of the Fingerprint Society in England said any fingerprint examiner who is swayed by stories and gory images is either totally incapable or is so immature that he or she should seek employment at Disneyland. In other words, their attitude is good examiners are not biased. If you are biased, that means you are bad at your job. One of the responses to our paper said the following: examiners want to read investigative reports because it allows them to enjoy their jobs and doesn't actually alter their judgment. So here we have sort of a two-pronged argument, both prongs being equally ridiculous. The first one is that forensic examiners are immune to bias. The second part of the argument being that we need that information not because it affects us or because we need it, but because it makes our job interesting. That obviously is not a good argument. And lastly, and this one is particularly frustrating in my opinion, some forensic examiners argue that having access to that information is important because it actually can make them more accurate. So they should not be blinded to irrelevant information. Instead, they should receive irrelevant information because it might actually help them. Now, this argument is, in my opinion, very misguided because, again, in order to have any confidence in the expert's opinion, we need to be sure that the expert's opinion is based solely on the evidence and nothing else. Think back to the Mickey Mantle baseball example, right? If you got the right answer just because you noticed that one baseball was less white than the other, you got the right answer, but that doesn't make you a fingerprint expert. So I would say that this argument is very, very misleading. But unfortunately, there are still a lot of people that continue to feel this way. Now, obviously, these are just a few anecdotal examples. We wanted to know what do examiners really think about this, right? Rather than looking at individual examiners and what they individually have said, we wanted to survey forensic scientists and get a better sense of what they believe and what they think they know about this topic. So a few years ago, we surveyed 400 forensic scientists from all around the world, and we asked them a whole bunch of questions about cognitive bias and what they thought it was and how they thought it could be fixed. And we found two very interesting patterns here. The first pattern is that forensic examiners showed what is called a bias blind spot. Let me explain what that means. On the left here, you can see three questions that we asked the people in this study. First, we asked them, do you think cognitive bias is a problem in the forensic sciences in general? And 71% of them, which is very encouraging, said, yes, I think cognitive bias is a problem in the forensic sciences in general. Then we asked them, do you think cognitive bias is a problem in your specific discipline? So in fingerprinting, in handwriting, in DNA, whatever it might be. The number dropped to 52%. Then we asked them a third question. Do you think your own judgments, you personally, are influenced by cognitive bias? Only 26% said yes. So the good news is experts are recognizing bias as a problem in general. The bad news is very few think that they themselves are affected by it. Instead, everybody's kind of pointing the finger at each other. Yeah, bias is a problem for them, but it's not a problem for us. Bias is a problem for him, but it's not a problem for me. And that kind of explains why there isn't a lot of progress being made here, right? If nobody thinks that they are part of the problem, they're not going to try to fix the problem. They're just going to continue blaming everybody else. So the bias blind spot is a broader term for the tendency for people to see themselves as less biased than they see other people. And this has been found in a whole bunch of domains, including racial bias, right? The average person thinks that other people are more racially biased than they themselves are. The second interesting finding to emerge from this study has to do with how examiners think bias can be avoided. We asked them, do you think that forensic examiners should be protected, shielded, insulated from potentially biasing information? And only about half of them said yes. Right above that, question 4 right here, we also asked them, do you think that an examiner who makes a conscious effort to be unbiased is less likely to be biased? A considerable majority of examiners agreed with that statement. So when we look at these two items together, it presents a pretty clear picture. By and large, forensic scientists see bias as an issue of ethics or willpower. That I can avoid being biased just by being aware of it and by trying really hard not to be biased. Now, we know in psychology that's not realistic, right? We can't just turn off our biases. We can't just choose to be unbiased. So there's clearly a disconnect here. The way to fix it, in actuality, is to protect them from bias by changing the procedures. But the way they think is going to work is just sheer willpower, which we know isn't going to work. Last thing I want to touch on is the fact that these people are experts, right? Forensic scientists are highly trained, highly skilled, highly experienced, so shouldn't their expertise protect them from bias? This argument has definitely been made by people who say, some of these studies haven't been done with experienced experts, and an experienced expert wouldn't show the same effects. Other people have actually argued the opposite, that being an expert might actually make you even more vulnerable to bias than someone who isn't an expert. Let's put this to the test. What I'm going to do right now is I am going to show you a sentence. I want you to quickly read that sentence. I'm only going to show it to you for about 3 seconds. I want you to read that sentence, and I want you to count the number of times that the letter F appears in that sentence. Okay, you ready? Got it? How many F's did you count? Did you count 3? Did you count more than 3? Most people, when they see that sentence, will count 3 F's. However, if you counted 3 F's, you were wrong. There were actually 6 F's. Now, what usually happens here is that people count finished, files, and scientific, but they miss the 3 ofs. They miss those 3 F's. So while there's actually 6 F's, most people will only count 3. This is because you all are experts at reading. And because you're an expert at reading, your experience with reading has taught you that the word of is a fairly unimportant word. So your brain kind of just skips over it. Even though it's there, you clearly saw it, you didn't process it because your experience has taught you that of is a relatively unimportant word. If you gave this same test to a kid who doesn't have as much experience with reading, they would actually be better at it than you because they would count the F's, right? Think back to last week when we talked about juvenile justice and we talked about the DRM paradigm. Kids are very literal, right? And this is a case where their lack of expertise actually benefits them. Whereas you, the expert, missed 3 F's that were right in front of your face. Researchers have called this the paradox of expertise. Becoming an expert means you can process information very quickly and very efficiently, which is generally speaking a very good thing. But in some cases, it can backfire. It can cause you to miss information that a non-expert might not miss, because your experience has taught you that you can use shortcuts and you can skip over things that your experience has taught you aren't important. So while some people have argued that being an expert might protect someone from bias, other people have argued, for this very reason, that being an expert, insofar as it makes you more efficient and rely on more shortcuts, may cause you to actually miss important information. Another example of this, think about when you first learned to drive. Everything felt very deliberate, right? You noticed everything on the road. You noticed every turn signal and every pothole and every this, that, and the other thing. Now that you are an expert at driving, your brain doesn't need to expend as much energy to drive. So you can process information a lot more efficiently. But you also might miss things that 17-year-old you didn't miss, right? Because you've learned that those things are unimportant. Oh, I don't need to read that sign. Oh, I don't need to look at that pothole, right? It's the same sort of thing. With experience comes efficiency, but efficiency also comes at a cost. And that cost can be attention to detail. The guy in the video that I'm going to ask you to watch now, this is E.T.L. Drawer, who's author on some of the papers that you read for today. He's really been one of the leaders in this field in terms of bringing awareness to this issue and trying to fix it. So what I'd like to do is have you watch this video. Go ahead and pause the lecture. You're going to start at 2 minutes and 15 seconds, and the video is about 3 minutes long. So go ahead. Okay, so there you got to hear right from the horse's mouth one of the leading experts on cognitive bias talking about the problem and talking about some possible solutions for it. One of the solutions that Dr. Drawer talked about at the end of the video has to do with controlling the flow of information to forensic experts, right? Making sure that they receive the information that they should receive and don't receive the information that they shouldn't receive that might create bias. And also making sure that when they analyze evidence that they do it in a very particular order and that they very carefully document their analysis, including how they arrived at their opinion and whether they made any changes to their opinion over time. That procedure is called sequential unmasking. Sequential unmasking is a procedure that has been developed over the past 10 years to essentially regulate how examiners receive information in a way that minimizes the risk of them being biased. Or at least if they are, if their judgment is biased, it becomes more transparent that they're biased. So using sequential unmasking, you might, for example, ask an examiner to look at each of the fingerprints individually before comparing them against each other. You might make sure that any information that might be biasing is either not provided at all or is provided later in the process after they've already formed an initial opinion. That way we can actually see if their opinion changes after they receive this new information. So as with a lot of the other reforms that we've talked about, that's one that's really geared toward transparency, making clear how exactly these decisions are being made. This is our last slide, and I want to leave you on sort of a radical idea and a very ambitious idea, but one that I think is very interesting. The standard practice, I've sort of alluded to this, but I haven't explicitly said it. The standard procedure for forensic examiners is to compare two samples against each other. One that's from the crime scene and one that's from a suspect. And their job is to determine whether those samples do or do not match. Now, if you think back to our discussion of eyewitness memory and eyewitness identification, this might remind you of an eyewitness show-up. Remember, an eyewitness show-up is where an eyewitness sees only one picture of one suspect and is asked to make a determination of, is this the person or not? The standard practice for forensic scientists is putting them in a similar situation, right? And we know that show-ups for eyewitnesses have been criticized as being suggestive. That the eyewitness looks at it and says, well, why would they be showing me this picture if they didn't have reason to believe that this is the person who did it? You could make a similar argument in forensic science, right? A fingerprint expert might look at a suspect's fingerprint and say, well, why would they show me this guy's fingerprint unless they think this is the guy? So maybe this is a bad idea. Maybe we shouldn't ask forensic examiners to do this. Maybe instead, we could keep borrowing from the eyewitness identification research, and we could actually show them a lineup, an evidence lineup. So that instead of comparing the fingerprint from the crime scene against one suspect's fingerprint, we show them 6 fingerprints, just like a lineup. One of these fingerprints, they don't know which one. One of these fingerprints belongs to the suspect, and the other 5 fingerprints are fillers. We know that the fillers don't match the crime scene, right? Maybe the fillers come from people who are already incarcerated or from people who are deceased, for example. So now the task is not, does this fingerprint match? It's which, if any, of these fingerprints match. Now, there's a few potential advantages to doing this. First, it's less inherently suggestive because, like a lineup, the witness may know that one of these people is the suspect, but they don't know which one, right? It's not suggestive in the way that a show-up is. Second, even if examiners are exposed to biasing information, this should actually offset the impact of that information. So for example, let's say the examiner knows that the suspect confessed. If they don't know which fingerprint belongs to the suspect, that information won't have the same impact on them. Third, and I think this might even be the most important one, Evidence lineups will allow us to have a better sense of error rates in the forensic sciences. Think about it. Under the standard procedure, they're comparing a crime scene fingerprint against a suspect's fingerprint. They make a decision, but we never really know if they're right or not, right? In the same way that show-ups can't produce known errors, the current procedure in the forensic sciences can't produce known errors. However, if we give them an evidence lineup, there's a possibility that they will choose a filler. And in that case, we know that they've made a mistake. That way, if we happen to notice that there's an examiner or a lab or a technique that consistently produces a lot of incorrect filler identifications, we can say this technique doesn't work, or we need to modify this, or we need to, train this person better. It will help examiners get a better sense of their own accuracy, and it will also help the courts be able to better evaluate how good examiners are at actually doing this thing. Now, as I mentioned before, this is a very new idea. There have been a few studies on it, but not a tremendous amount of research on it. But it is an idea that some forensic scientists actually seem to be open to. In fact, the field of bite marks, or forensic odontology, as it's more formally called, they actually recommend now that their examiners make identifications from lineups. So it will be known if they make a mistake, if they pick a filler set of teeth that does not match the bite mark that they're trying to analyze. So we have a couple potential reforms here that might work. Between sequential unmasking and evidence lineups, we have some promising ways for forensic labs to avoid this really dangerous cognitive bias that, again, examiners can't just switch it off and fix it on their own. The trick now is going to be persuading the forensic science community that this is a good idea. Not only that it's beneficial, but also that it's feasible. And that's kind of where we're at right now. So again, as I mentioned, next week we're going to sort of continue with this topic. We will look at a wrongful conviction that was based primarily on flawed bite mark evidence, and we'll see some of these issues come up again. So I look forward to getting your impressions on that case. All right, see ya.